Alright, so today in class we did work with acceleration. You should have already read through this section so you have a familiar idea with this. This video is going to focus on the that additional box of equations. Alright, so if you are having issues with the basic acceleration equation, the a equals v minus v naught over t, or if you're an IB, a equals v, I don't know if you're an IB, minus u over t. If you're having issues with that equation still, watch the video before this. It is more or less a repeat of what we did in class. It's slightly different, but that'll be a good review on this one. This is going to get into the more complicated equations. So, just some stuff to mention. We have these different lettering styles based on the possible tests you might take in order to get college credit. Alright, so we have three similarities. V by itself stands for final velocity. Acceleration always stands for time. A always stands for acceleration, and T always stands for time. If you're an IB, you kind of have to memorize these guys, and if you're an AP, or going to take AP, you have to memorize those guys. Or at least remember them. Also, I would use the equation sheet that matches, your preference as far as which one to use. So, let's look at these new equations. So, the first one, this is just the acceleration equation rearranged to solve for final velocity. Okay, so we've already dealt with that one. The other two come in to play when you are missing bits and pieces of this information, or you're given distance, or need to find a distance, or something like that. So, big thing if you're trying to find distance and you're given a time, you use the second version because there's t in there. Alright, if you're not given a time, then you have to use the second version of this. Okay, something just to note, in this picture, or in the slide, I did format the IB equations to exactly match the AP ones. On the equation sheet, when you take an IB test, they don't include the initial position, alright, and I believe they also don't include the initial velocity. That doesn't mean that they won't be there, it's just that's something you have to remember to include. You have to add in the initial position, and you have to multiply the initial velocity times the same amount of time everything takes. Okay? But just keep in mind that this can still be part of the equation. So let's to a few problems. Alright? This is where doing SU comes in really, really handy. And in fact, I actually prefer to do something called LESU, where you list out what you know and assign the variables to it so that you can see how it's going to plug into your equation. Plus, knowing what variables you have might help you pick out your equation. Okay, so we're going to do LESU on this one. And L just stands for listing your knowns. Okay. So we have an airplane accelerates down a runway at 3.2 meters per second squared, or meters per second for 32.8 seconds. How far did it go? Okay, so we know our acceleration is 3.2 meters per second squared. We have a time of 32.8, alright, and seconds. We have a question mark of x, or S, depending on which class you're in. Okay? For the most part, I'm going to try, because the book doesn't give practice with the IB equations, and the most part of the videos I'll try using the IB stuff. So, we want to find, it doesn't say anything about this, and if it doesn't, you can assume that your initial velocity, your v naught, which is also u, that's 0. Okay, unless it tells you something, you can assume it's 0. Sometimes it'll say starting from a rest or coming to a stop, and then it implies. Alright, so we know enough to use this equation. So here's our L, here's our E. S equals 1/2 AT squared. Alright, I didn't write in the SO or the plus ut, because this is a 0 and this is a 0, so those end up just getting kind of knocked off. So if we solve, our position is 1/2 times 3.2 times 32.8 squared. One thing, careful when you plug that part into the calculator, the only thing that is squared is the 32.8. So make sure you're following your order of operations. So when you plug this in, you should get approximately 1721.34. I'm not keeping up with sig figs. That is okay. And since we're solving for a position or a distance, our answer would be in meters. Okay? So that's how you use this version. So if you're given a time, use the equation that includes time. Here's an example of something that doesn't include a time. So it was once recorded that a Jaguar left skid marks 290 meters in length. Assume that the Jaguar skidded to a stop with a constant acceleration of negative 3.9 meters per second. Determine the velocity of the Jaguar before it began to skid. So what do we know? We know that our final distance, which is also our final position, is 290 meters. All right, and that is assuming that XO or SO is 0. All right, it doesn't give us an actual position that we're starting at, so we can just make that assumption. We also know that our acceleration is negative 3.90 meters per second squared. My squared got cut off, sorry there. And we also know that our velocity, our final velocity, all right, is 0 because he comes to a stop. Our question is our initial velocity, or our u. Okay, so here was L. Here's E. The equation we're going to be using for this one is the velocity final squared equals initial velocity squared plus 2 times acceleration times your position, your final position minus your initial position. Okay, so again, this one really didn't even need to be written because that's 0, so that's going to cancel out. There's also the fact that our initial velocity is what we're trying to figure out, so never mind, scratch that part. So let's plug it. So we know our final velocity is 0, and 0 squared is 0, so I don't need to write the squared part. And that's going to be equal to u squared plus 2 times negative 3.9 times 290. So you end up getting S. When we solve that, you end up getting u squared. Let's see, I don't want to skip too many steps, so let's stick with 0 equals u squared plus r 2 times negative 3.9 times 290, negative 2262. And you don't always have to show out this many steps. I'm fine if you stop here and then do the math, but just so that you see where I'm coming from on solving this. What we do is we add the 2262 to both sides, 2262. So we have 2262 equals u squared, and then to get our initial velocity by itself, you just take your square root. So u equals 47.56, and our units, so that we don't forget our lesu u, is meters per second. Okay? So we'll practice some more with this, problems from the book, things like that. Please bring any questions that you have to class, and make sure you do the online form.